Good afternoon, everyone. I think this is lecture 10. Okay, so lecture 10 will basically be exercises of what we precised as homework during the last session. So in exercise number 22, consider a monochloric acetic acid solution. So look at the acid. You can definitely see it's a monoprotic acid. And just to be sure, تأكدوا إنه في بس 1 pKa given. And it has a concentration of 10 to the negative 3 mole per liter. A dilution is carried out that is basically 1 to 50 of the initial concentration. Okay? It means that the initial concentration was diluted 50 times. Yani C0, let's say this is the initial concentration, is 50 times the new concentration, or what we call the dilution factor. It's the same thing. Knowing that the pKa is 2.90, which of the following statements are correct? Let's see. أول شيء خلينا نلاقي the new concentration. If the concentration is basically C0, which is 10 to the negative 3 divided by 50, and it's basically 1 over 5 times 10 to the power negative 4, so that's 0.5. فينا نحطها دغري 2 times 10 to the power negative 5. Okay, so which of the following statements are correct concerning the obtained solution? This is now the concentration. For the estimation of the pH of the solution, the dissociation of the acid can be neglected. Dissociation of the acid, yani you can neglect A minus. When can A minus be neglected? A minus can be neglected when, remember, pH equals half pKa minus half log C less or equal pKa. في condition تاني قلنا عنها, it's a very easy condition, is when the initial concentration is greater or equal to 100 times Ka. Now pay attention to this trick. The concentration in your solution. In your solution, the concentration is the new concentration, 2 times 10 to the power negative 5. It's not C0, okay? It's C because they did a dilution. Is this C greater than 100 Ka? The Ka is basically 2.9. أكيد 10 to the negative 2.9 لأنه this is your pKa. Is the concentration greater than 100 times 10 to the power negative 2.9? يعني is it greater than 10 to the power negative 0.9? No, it's not. So this is not correct. Okay, the pH كيفنا نعتمد the first validity دغري نتأكد لأنه at the end they did ask for the pH. What is the pH? The pH is equal to half pKa minus half log C. If it's less or equal than pKa minus 1, هي 2.9 minus 1, so that's 1.9. Remember إنه هيدي حتطلع غلط لأنه أنتوا أصلا ب option A قلتوا إنه the concentration is not greater than 100 Ka, so A minus cannot be neglected, so this pH will be wrong. انتوا عارفين من الأساس إنه this pH will be wrong. Half pKa minus half log C will basically be equal to 3.80. Is it less or equal than 1.9? No, so this is also wrong. The auto-ionization of water is not negligible. No, بالweak acids نحنا we said that the auto-ionization of water will always be negligible. And anyway, look at the concentration. The concentration is enough. So this is no. For the estimation of the pH, it is necessary to solve a second degree equation. Well, as long as this is incorrect, then yes, you do have to solve a second degree quadratic equation. Okay? The pH is 4.71 times 4.71. You have to solve the quadratic. Okay, so basically just solve the quadratic. You get the value of Ha3O plus, and from the value of Ha3O plus, you find the pH. Very easily. Remember, in these type of questions, you may have more than one answer. okay? I don't have a scientific calculator to do the calculations. Let me check. So simply do the calculations. If when you solve it, you get 4.71, then yes, it is this is the correct pH. Number 23. What is the nearest pH value of a hydrochloric acid solution? So this, just check it, okay? Calculate the pH and see if it's equal to 4.71. What is the nearest pH value of a hydrochloric acid solution? Remember, hydrochloric acid solution is HCl. Between bracket, this is a strong acid. If you don't know it's a strong acid, look at the question. Do you have a pKa given? No, you do not. Then, it's a strong acid. And the concentration is 10 to the negative 8. تتذكروا ال validities, if the concentration is greater than 3.2 times 10 to the power negative 7, then the pH minus log HA3O plus. If it's less or equal than 1 times 10 to the power negative 8, the pH is 7. So, very quickly, 7. Look at the validities. بالvalidities كان عندي 3.2 times 10 to the power minus 7 greater or equal. كان عندي less or equal than 1 times 10 to the power negative 8. وكان عندي in between, which is basically the quadratic. So since this value is provided, then the pH is degree 7. Okay? Number 24. Assume that for the given concentrations, the standard hypotheses are valid. Okay, calculate the pH of a solution obtained by dissolving 0.12 grams of sodium hydroxide. أول شيء, let's write it. Sodium hydroxide is NaOH in 500 ml of H2O. Basically, you just have to calculate the concentration of sodium hydroxide in your solution. كتير منيح. The concentration of sodium hydroxide, it will be the same as HO minus. Why? Because when sodium hydroxide dissociate, it will give you 1 Na plus and 1 HO minus. The concentration of this is the same as the concentration of this. So let's calculate the concentration. كلكم بتعرفوا إنه concentration هي basically mole per liter. Okay, the mole is basically grams per mole. So this is grams per mole liter. Mass divided by molar mass times volume. Okay, أكيد هيدي gram per mole. So it's equal to mass 0.12 grams divided by the molar mass. كنا بنعرف how to calculate the molar mass of anything. Basically, NaOH هي Na23 plus the oxygen 16 plus the H, which is 1. Okay? Times 500 ml, 2 liters. This is 0.5. Okay? So, you get an approximate value, I think, of 6 times 10 to the power negative 3. I'm using the laptop calculator, so always check. This is your concentration. According to the validity, the concentration of HO minus is greater than 3 times 10 to the power negative 7. دغري بروح إنه pH is 14 plus log HO minus, because this is a base, which is basically 14 plus log 6 times 10 to the power negative 3, and I think it's 11.8. Again, verify. Number 25. Consider a solution of potassium hydroxide. Same thing, but instead of sodium, we have potassium. So this is KOH. Again, strong base. If you don't know it, look, do you have the pKa given? Concentration is 0.05 mole per liter. The following dilution is carried out. 10 milliliter of the solution is placed in a 500 milliliter flask and distilled water is added. Yani you dilute to 500 ml, from 10 to 500. Which of the following statements are correct concerning the obtained solution? Okay, what is the new concentration? What is the new concentration? You either multiply by the dilution factor أو بتتبعوا الطريقة القديمة, which is basically 0.05 times 10 is equal to the new concentration هي HO minus times 500, which is هون milliliter will cancel milliliter, okay? And this is basically 0.05 times 10 divided by 500, which is 10 to the negative 3, okay? 1 times 10 to the negative 3. Remember, you can always multiply by the dilution factor. يعني من 500 ل 10. Okay, so I think the first one is correct. Yes. Good. The concentration, لا نتبع الباقيين, maybe we have another answer. The concentration of H3O plus is 1 times 10 to the power negative 3. Absolutely not. I don't have to calculate it. But if you do need to calculate it, كلنا بنعرف إنه ال KW, which is basically 10 to the negative 14, مع إنه ما قالوا لنا إنه it's 25 degrees Celsius, but always assume it's equal to H3O plus times HO minus. So you know how to calculate it. You don't need to, because you know it's definitely not 10 to the negative 3. Okay? The formula, pH equals pKu. So this is W, pKw, which is 14, plus log C can be applied where C is the concentration of potassium hydroxide in the solution. When they say in the solution, yani in the final solution, in the diluted solution, then yes, because the pH can be calculated from 14 plus log HO minus, on the condition that HO minus is the new concentration. Remember that. So this is also correct. إذا كتبوا the initial concentration before dilution, no, you cannot, because they don't take into consideration the dilution. The pH of the solution is 12.7. Let's find. So it's 14 plus log HO minus. No, it's not 12.7. The pH of the solution is basically 11. No, it's 14 minus 3. 3 correct answers. Number 26. A solution is prepared by dissolving 1.24 grams of ammonium chloride اللي هي NH4Cl in 250 ml of H2O. Okay, among the pH values below, which is the nearest to the pH value of the solution? Now, when they say which is the nearest, approximately what is the nearest without calculation. However, it's always better to just calculate. To calculate, simply find the concentration. A small thing that you have to pay attention to. The concentration of NH4Cl is the same as the concentration of NH4 plus. Why? Because when this dissociates, it will give you NH4 plus and Cl minus 1 to 1. However, when you calculate the concentration starting from the mass, you have to use the molar mass of NH4Cl, which is basically the mass 1.24 the grams divided by the grams per mole. جمعوهم كلهم 35.5 plus 14 plus 1 times 4. Okay, you get 35.5 plus 14. Okay, you get an approximately, I think, 35.5 gram per mole. Okay, times what's the volume? 0.25. Be changed to liters. Okay, so this gives you a value of 0.093 molar. Good. Now we already know إنه when it dissociates it gives you NH4 plus. NH4 plus is a weak acid. You start by applying the validity of the weak acid. أول validity اللي هي pH is equal to half pKa, so that's half 9.2 minus half log C, so that's basically 0.093. Okay, is it less or equal than pKa اللي هي 9.2 minus 1, so that's 8.2. Calculate this, you get a value of 5.12 less or equal than 8.2 valid. Then your answer is 5.12. Okay, pay attention هون للتريكي كتير صغيرة. أول شي the salt dissociates completely, one arrow to give you NH4 plus. وبترجع ال NH4 plus dissociates with water as a weak acid to give you NH3 plus H3O plus. So you actually have two reactions. The first one is not taken into consideration لأنه it's a complete. We Cl minus is a spectator. If you have a binary salt, it changes. If you have a tertiary salt, it changes. So pay attention إنه this number, هيدا ال1, is the same as this number. Now, number 27. Calculate the concentration of carbonate ions in H2CO3 solution of concentration 0.025. Pay attention to the question. The question says that in your solution you have H2CO3, which is the acid, and this acid has a concentration of 0.025. And now you have to find the concentration of CO3 2 minus. Remember? حلينا مثله وقلنا إنه this value is, if you can neglect the second acidity, the value of the second base will always be equal to Ka2. تتذكروا? So instead of solving the question فيكن دغري تحطوها equal to Ka2 اللي هي 10 to the power negative 4.7 times 10 to the power negative 11. But just to be sure لنأكد, okay, since Ka1 is greater than 100 Ka2, the second acidity is neglected. Good. What do? You can find the pH as it's a mono acid starting from half pKa1 لأنه قلنا second is neglected minus half log C. C is 0.025. Make sure that the volume did not change. It did not change. So that's 0.025. This will be equal to 3.97. Is it less or equal than pKa minus 1? Okay. Minus log 4.4 times 10 to the power negative 7 is basically 6.35 minus 1, 5.35. Yes, it's valid. جبتوا ال pH. How does the pH help you? Because the pH tells you that H3O plus at equilibrium is equal to HCO3 minus, and it's equal to 10 to the negative 3.97 from Ka2. The Ka2 is equal to basically CO3 2 minus times H3O plus divided by HCO3 minus. You know that these two have the same value, Newton X, cancel. You get CO3 2 minus equal to Ka2. Instead of doing all of this, remember, if you can neglect the second acidity, اللي هي Ka2, then the second base, the A2 minus, is always equal to Ka2. Okay? If you cannot neglect the second acidity, the value will change. Make sure that the conditions fit. Calculate the pH of NaCN solution of concentration 0.6. طيب, good. أول شي, what is NaCN? NaCN is a salt that dissociates completely to give you Na+, which is a spectator, and Cn minus. Now Cn minus behaves as a base. It reacts with H2O to give you HCN plus HO minus. How do you find the pH of a base? Look at the initial concentration. Okay? And assume that the conjugate acid HCN is negligible, then the pH is equal to, remember, 7. For bases, it's 7 plus half. عندي بس 1 pKa لأنه it's 1 basicity plus half log C. If it's greater or equal, then pKa plus 1. So 7 plus half pKa. أول شيء find the pKa, which is basically negative log Ka اللي هي 6.2 times 10 to the power negative 10. أو NaCN is always around 9.2. Okay, so pKa اللي هي 10 to the power negative negative log Ka is equal to 9.2. So that's 7 plus half, 9.2 plus half log C. This will give you 11.5. Is it greater or equal than 9.2 plus 1, 10.2? Yes. This is your pH. 11.5. Actually, it's 11.49. And I did an approximation, which is why it's important in pH you don't approximate. Okay, another recording.